Okay, so now we're on to question. So we have a graph or a diagram of free energy versus the fraction of A that reacted. Question A, what is the sign of delta G for this reaction? And B, what is the sign of delta G initially before A reacted? So let's try to draw this graph as well. So we have G, and down here we have the fraction of A reacted in thirds. And it looks like we have a minima in our graph right at 0.33. I'm just going to roughly sketch this out. Starts off like here, and then a minima, then it just kind of shoots up. Okay, so now for part A, what is the sign of delta G for this reaction? So we know that delta G of a reaction is equal to delta G of our products minus the delta G of our reactants. So if we look at our graph, you can see that the Gibbs free energy of our reaction increased as more A reacted. So this tells us that the delta G of our products is greater than the delta G of our reactants, and this tells us that the delta G of our overall reaction would then be positive. If the delta G of our reactants was greater than the products, then we would get a negative delta G. Okay, so that's part A. And then for part B, I'll write over here, what is the sign of delta G initially before A has reacted? So first, let's find our equilibrium point, which is the minima in our graph. So at equilibrium, delta G of our reaction is equal to 0. And this is also the minima of our graph. So it's shown here, so let me just label it. So after equilibrium, our free energy of the reaction increases. So you can see that it shoots straight up as delta G is positive. So this tells us that initially delta G of our reaction is negative. Okay, so let's see what the junior tutor said. Delta G for the reaction is calculated by the delta G of our products minus the delta G of our reactants. Since the diagram showed that the free energy increased as more and more fractions of A were reacted, it means that the delta G of the product is greater than that of the reactants. Therefore, the sign of delta G for this reaction is positive. Yep. And there is a point in the graph where G reached a minima, the lowest point in the graph, which means that the equilibrium is reached. Equilibrium is when the delta G of the reaction reaches 0. After that, the G increases, which means that delta G becomes more negative. Therefore, the sign of delta G initially should have been negative. Okay, so this solution is correct.